using a phase diagram to find a phase transition temperature or pressure. So what you need to do here is we've been given a temperature and then told at this temperature the pressure is lowered and asked at what pressure the sample will melt. Okay, so what we first of all need to do is find our minus 66 Celsius line. So we have to convert this into Kelvin. So temperature is minus 66 plus 273, so that is going to be 0.15, 207.15 Kelvin, but I'm not going to be able to get the 0.15 on this scale. So 1, 2, 3, 4, 5. So each of those minor check marks is 40 Kelvin. So 207, I'm going to just draw a line here. In fact, I think this particular question, it does actually give you a line that you can kind of, there you go. So if I can try and find the, it doesn't work particularly well for me, but here we go. 207 is going to be about here somewhere. Oh, it's doing crazy stuff. I would have been better off drawing my own line, I think. Okay, so 207. At what pressure will the sample melt? Okay, so melting is implying going from the solid phase to the liquid phase. So basically, we are somewhere. I should draw my own line. Right, line, go away. I'm drawing my own line. It's just not working very well on my computer. So this is my 207 Kelvin line like that. If it's asking about the sample melting as the pressure is being lowered, then that is implying that we are moving from up here somewhere down until we cross that solid liquid line. So from what I can see on the size of my diagram here, it's gonna be about here. Well, that's conveniently on a line. Okay, so if I then extrapolate across to intercept my pressure axis, I would say that's about 0.4 atmospheres. So I would say that my sample will melt at 0.4 atmospheres. Hopefully that's good enough for Alex. It's good enough for me. I wanted to do another one of these to show going back the other way. So we're this time trying to work from the temperature to the pressure. So the pressure is 0.46. Each of these check marks is about 0.4. So 0.46 will be just above this line here, something like that. Okay. So we can see where we cross the solid gas line here. That is going to be where we sublime from a solid to a gas. So if I drop a line down from that intersection, that is the temperature I'm going to have to read off in Kelvin, but I'm going to want to then get that into Celsius. But one thing at a time. So if each of these check marks is 40, 160, 120, 80, that's going to be like 100 and something. I'll say about 105, 110 Kelvin. Then we're going to convert that into Celsius. So we're going to subtract off minus 273, 105 minus 273. It's going to give me about minus 168 Celsius. It says answer within 20 degrees Celsius. Hopefully I'm close enough. I don't know. All right, so that's what we'd have to do if we go back the other way. Just make sure that we are actually converting that into Celsius from Kelvin.